Welcome everyone. It's a pleasure to have you with us today. So my name is Yue Li. I'm an associate professor from Xianzhao Liverpool University in China. And today we are very delighted to welcome you to this webinar and to connect with colleagues and researchers joining us from all around the world. The empathic computing.
It's 16 hours.
Sorry, it's my
现在是北京时间下午4点整。
That's my clock. So our journal launched the webinar series to facilitate scholarly exchange and to enhance the visibility of the research, creating a platform for dialogue among leading researchers in the field. So for those who like to learn about the journal, please visit our journal website or feel free to contact us via email. So today we are very honored to welcome Professor Ken Pfeffer from Aarhus University, a leading researcher in human-computer interaction and extended reality, whose pioneering work on gaze and spatial interaction is helping shape the future of user interfaces. He will share his insights on eye-hand symbiosis and discuss how the integration of gaze and hand interaction is shaping the future of human-computer interaction. We are also very delighted to have Professor Jason Alexander from the University of Bath, United Kingdom, joining us today as for the discussion. With his extensive expertise in human-computer interaction and emerging interaction technologies, we look forward to his valuable insights during the discussion session. So before the presentation, I'd like to take a moment to briefly introduce our journal so that scholars who may not be familiar with the journal can get an initial understanding of it. So, this journal is an international gold open access journal launched in 2025, dedicated to providing a high quality academic platform for researchers worldwide. The journal adopts a rigorous single-blind peer review process to ensure fair and unbiased evaluation while encouraging constructive and detailed feedback from reviewers. With a target impact factor of 6, EC aims to become a leading journal in this field, advancing excellence and innovation in research on empathic computing and collaborative technologies. To foster academic exchange and attract high-quality submissions, EC has introduced an annual Best Paper Award to recognize outstanding scholarly contributions and will waive all article processing charges until 2029. In addition, we provide multi-channel academic promotion for published works, and exceptional articles may be selected for customized academic presentations. Please feel free to scan the QR codes below and follow our journal updates, and you may take a screenshot to save them. So taking a look at the aims and scope, EC is a peer-reviewed open access journal published quarterly that explores technologies that foster empathy and shared understanding, including AR, VR, physiological sensing, and AI-driven emotion recognition. It aims to transform collaborations through natural interaction, implicit understanding, and experience capturing and sharing. We cover a wide range of subject areas, including but not limited to collaborative VR, AR, and MR, using sensors for emotion recognition and sharing, capturing and sharing real environments, machine learning and AI methods for emotion recognition, novel collaborative interfaces, and so on. So we do welcome scholars from all around the world to engage with the journal, submit their research, and contribute to advancing knowledge in these critical areas. So for more details, please scan the QR code and visit our website for more information. So this journal is an international peer-reviewed journal with distinguished editorial board. It is chaired by Professor Mark Billinghurst, who holds joint appointment at the University of South Australia and the University of Auckland. His groundbreaking work on AR, VR, MR, HCI, cognitive neuroscience, and empathic computing has had a significant impact worldwide. And our editorial team includes an executive editor and 8 associate editors affiliated with leading institutions worldwide. And we also benefit from the expertise of 27 editorial board members and 8 youth editorial board members from all around the world. And this contributes to a diverse panel of 35 distinguished scholars across 23 countries worldwide. The international team is dedicated to maintaining the highest standard of academic excellence and ensuring that the journal remains at the forefront of empathic computing research. EC continues to expand its editorial board and welcomes outstanding scholars to join us in advancing this dynamic field. So now it's my great pleasure to introduce today's speaker, Professor Ken from Aarhus University, Denmark. So Ken is a renowned researcher in human-computer interaction, extended reality, and next-generation user interfaces. Today, he will present his talk, Eye-Hand Symbiosis, and share his insights into how the integration of gaze and hand interaction is shaping the future of human-computer interaction. Meanwhile, we also have Professor Jason Alexander from the University of Bath joining us today. So Jason is a leading researcher in human-computer interaction with extensive contributions to interaction techniques, haptics, shape-changing interfaces, and immersive technologies. So we really look forward to his insights and comments during the discussion session later today. So during this talk, we have the free discussion. So before we begin, I would like to briefly go over the discussion guidelines. So during the presentation, please feel free to share your questions in the chat box. If you'd like to speak during the discussion session, kindly raise your hand and wait for the moderator's invitation. We encourage all participants to use English during the discussion and to respect different viewpoints. So with that, Ken, thank you very much for joining us today. We are delighted to have you with us, and the floor is all yours. I will stop sharing, and you may share your screen now.
Okay, I will do that in a second. So, background. So let me know if you can see everything.
Yes, we can see the screen.
Okay, good, cool. Yeah, first of all, thank you for the invitation again. I'm also happy that I joined this forum last year and just got to know a lot more about what's happening in the interesting intersection of empathic computing that does include XR and a lot of other technologies. My name, as you've already mentioned, my name is Ken Pfeiffer. I'm an associate professor now in Denmark, Aarhus University, and I do a bunch of different research direction within the areas of HCI and VR/AR. And one stream of research is the Eye-Hand Symbiosis that I've been kind of following with a lot of different collaborators and within different research groups since Lancaster University, where I first started actually with Hans Gellersen and Jason Alexander, who is here today. So it's going to be a great, but also a weird way to reconnect back to the basics, where I will also talk about some of the more original work from then. So my big focus for the last probably 10, 11, 12 years has been the Eye-Hand Symbiosis, where the idea is to explore how the control of computers can be done by eyes and hands. A little bit about my background, but just quickly, you already mentioned a bit, but I grew up and I studied in Germany. And then I had this time in UK, and in that I also had a few stays in the States. We did research internships with some design and HCI people, and they've also influenced me a lot. And I went back to Germany for my postdoc, and then for now, for about 5 years, I'm in Denmark. I'll kind of jump right into the topic. So you might have seen that in the recent years, so since around 2024, there's been new devices, new XR devices like the Apple Vision Pro, where a major input paradigm is now to use your eyes and hands. So you actually look at different icons, and then you can do, for example, like a pinch gesture and moving your hand slightly to make the click in a way. So the mouse pointing is essentially replaced by your eyes in 3D space, and you can do a click command. And of course, there's been a lot of other innovations happening with immersive devices. And you can see them with the advancements from Oculus to Meta to Apple and Google, and it's a lot of devices that are, some of them are out. Of course, Android XR is out now with the Galaxy XR device, and you can you can have also this more spatial experience of having all your virtual content in your scene. And the highly interesting part is that the interface really changed to integrating both eyes and hands, while in the history of computing, any consumer device was operated by the hands. So that's kind of an interesting. So on one side, it's interesting in itself that how can we integrate our eyes as a control medium into the interface? But it's also just a very surprising thing. When you actually try it out, it feels somehow very different, but also familiar to how we normally control computers. And I wanna talk about the scientific foundations of this, and why I'm specifically bound to this topic, and also some prior work we did about 10 years ago. And I selected like 2 examples. For example, the Gaze and Pinch paper is a bit more known nowadays, but that one is about specifically the design of a paradigm where you select with the eyes and pinch with your hands to manipulate objects. And there's a lot of different details into the actual design, because there's a lot of ways you can combine the eyes and hands. And but there's only one to rule them all in a way. Anyway, the other paper, however, they got a bit under the radar, and I think that's also one wouldn't work with the other in a way. And I will explain this more during the talk. But it's the idea of direct and indirect gestures. So you can both you can do one gesture, one input command with your hand, but it can be either direct or indirect, depending on your visual attention. And this also has been adopted in the same system in the operating system by Apple, but also in other devices. I think it's increasingly part of it. At least I think it makes the whole fragmented input space, it makes it much clearer that there's 2 different modes that you can use with every input device. But yeah, overall, I was just always somehow struck into this topic that, okay, we have our eyes, we have our hands all the time on, and there's a lot of other things in the human body, of course, but specifically our eyes indicate actions in so many times during the day. Whether we use our phones, whether on the desktop with a mouse, it just happens so often that this has to be taken advantage of to fundamentally improve human-computer interaction. It's interesting to go back in time to see, okay, when did major changes happen in the user interface evolution? And of course, this is stretching it a bit, going back 2 million years. I know we've the first tools that humans use to manipulate objects, to manipulate the world, and that's something that has millions of years of evolution of how our hands evolved to use different tools, how we understood how we can appropriate the world to create new tools. And of course, in the digital age, this has been accelerating a lot with new types of input devices, from the keyboard, the mouse, stylus, and touchscreen. A lot of things invented, at the beginning, in the 50s, 60s, 70s, that we are using now with pointing devices, and even Sutherland's first VR demonstration. And so a lot of things were actually indicated already in the past, and major impacts. I mean, all of them had a huge impact, of course, in a lot of different use cases. But you can say that the mouse, in the 80s, when it got industrialized, it had a huge impact, because now every person could understand, okay, there's a little cursor moving on the screen. It is more intuitive than it was before, where it was mainly a mainframe interface. So it can reach a lot more people. And of course, a more modern take on this is the smartphone. When a huge impact did it have around 2006, when Steve Jobs announced the first iPhone, for example. But there's been a lot of work on mobile devices before and afterwards. And we can also see this coming now in this new era of extended reality. So we have a lot of VR devices that are working now, that can be put in our home, but we also see the new trend with all the companies going for AI and AR glasses, so a more mobile form factor. So you can use it anywhere and anytime. And that's something potentially to come in the near and midterm future. And I want to say why is specifically the input device so relevant, right? Because there has to be a lot of innovations happening at the same time to really make a huge new leap in how the technology works. Like when the mobile phone came out, of course there was mobile technology, wireless technology, the internet, big data, processing power, display quality. A lot of things came together, of course. But there is something about the interface, the input device, that is a key element. And you can see this in these two videos. So these are at the time 2007, when this paradigm shift happened from actual physical button interfaces to a multi-touch screen on the phone. And this is Steve Ballmer on the left. At the time, he was the Microsoft CEO, and on the right, Steve Jobs, who was the Apple CEO. And they have very interesting takes in their public-facing interview. So, of course, the second one is not an interview, but I want to just play it to see what are they actually saying? How are they augmenting for their mobile device future at the time?
Steve, let me ask you about the iPhone.
This is a little. It's going to be a little louder.
And the Zune, Steve, let me ask you about the iPhone and the Zune, if I may. The Zune was getting some traction, then Steve Jobs goes to Macworld and he pulls out this iPhone. What was your first reaction when you saw that?
$500 fully subsidized with a plan? I said, that is the most expensive phone in the world, and it doesn't appeal to business customers because it doesn't have a keyboard, which makes it not a very good email machine.
So, interesting take. Of course, it's expensive, but that's not a major thing. But the keyboard is something that Steve Ballmer is emphasizing here, and that's interesting, because if you think of Microsoft, they have Microsoft Office, Windows. They use the mouse and keyboard as the main, their customer base uses that. So they are thinking about their main customer base, and they need a keyboard. They need to be productive. So in the time, Steve Ballmer thinks, okay, without a keyboard, it's not gonna work. And that is understandable. But of course, it's also a little bit of a legacy thinking in there, thinking that we know how computers work, we have our customer base, and we want to adopt it now. We want to bring it on the phone. But it's sometimes you need to have a different approach. So let me show you what Steve Jobs was saying.
A giant screen. Now, how are we going to communicate this? We don't want to carry around a mouse, right? So what are we going to do? Oh, a stylus, right? We're going to use a stylus. No. No. Who wants a stylus? You have to get them and put them away and you lose them. Yuck. Nobody wants a stylus. So let's not use a stylus.
So, of course, after that, he says, let's use our finger. But it's interesting that he says, we don't want to carry around a mouse. And that's kind of an obvious thing, right? That on the go, you don't want to have another device to be attached to the phone. And then the stylus. The stylus has been proposed as an input device for phones for longer already. So it has been there, and people were like, okay, why don't you just use the stylus? But he makes it very clear, it's, just from a personal, basic customer perspective, it's just too much already. 2 devices are too much. So this is kind of 2 very different takes, but what I interpret into Steve Jobs' take is that if we have a new device category, it's for a new context, and you cannot just import the existing input methods into there. So that's one thing. So completely reinvent what you have in there. That's a key aspect to innovation research. And the other aspect of it is that when you talk to the people, they don't care too much about a few more pixels here and so on. It's really about, how can I immediately access the device and get online or get to all my services? And that's the thing with multi-touch, that it just changed it a lot. And nowadays, that's the dominant input method. So let's get back to okay, a bit more zooming out. But what's happening here is that you want to keep it as simple as possible, and the simplest things are, in a way, those things that are on you. You know yourself, you know your body, you know how your body moves, you have perception, and the intuition of how things from the real world actually work and how you can apply them to the digital context. And just think of, in 100 years, maybe we don't know anymore how a phone works or how displays work in our environment. We just know very basic things that are constant. So in 100 years, maybe technology will change fundamentally. And that's very likely, right? Every 10 years we have big changes, but the human body, how it works, this will stay a constant, right? Even in 100 or 1,000 years, it's very likely that we still have our hands, we still have our body. So that's something if you want to go beyond specific innovations in technology, you have to consider the human aspect of it. So, but getting back to extended reality is a very interesting aspect there, because it kind of is the idea of computing in spatial, right? In the space, in 3D. Displays can be anywhere. They don't have to be physically put onto the tables. So I love to just have my, when I'm in the evening, when I'm watching Netflix or something, I love to just lie down and have my screen exactly where I want it in front of me, instead of me having to adapt to a physical arrangement in the room. But the big question there, similar to smartphones for multi-touch and so on, but the big question for XR has been for a long time, like what is the right input? Because if any content can be in space, then it's quite challenging to actually interact with it, right? That some things can be far away, some things can be close. A lot of visions from science fiction, like Minority Report and so on, they are based on a lot of gesturing around with your hands, which can, compared to how you use your mouse or touchscreen, it's about very small movements you do with your hands. So very small physical effort from the human body can control a lot of things in the digital world. So having to gesture around a lot is over time it can get fatiguing. It's nice for use cases like sports and games and fitness, of course. But on the other side, if you think of productivity, for just basic information and media consumption, then it's nice to have this very low effort way of interacting. And in XR, there's been the second wave kind of with Palmer Luckey and his team introducing Oculus at the beginning, that led to a huge new wave of a lot of VR and AR devices. So here, this is a recent infogram made for 12 years of about 40 devices, I think. And initially, there was quite a fragmentation with a lot of types of inputs and often using the device itself as a pointer. And that actually, of course, that can be a bit fatiguing for the head if you always have to move your device or the head around. And that kind of was superseded by the controller. So now, since spatial tracking got better, a lot of devices are now based on controllers, and they are very precise. But that also is again this iPhone case or the mobile phone case where you have a stylus. So you always need to carry around another device, and it's not so hard to carry it around, and it's nice to have in the lab. You can just have your controllers lying around, or at home, or in the office. But if you think of just an everyday environment, you just put on your glasses or your headset. If you always have to take up your controller, it's a little bit more effort already. And the thing is, if you explain it to someone, hey, I really want you to get the experience of my of this new cool app I built for VR, and then you can put the headset on, and then you want to put the controller in someone's hand, and first you need to explain, okay, which button does what, how do I use the controller, and that's already quite a barrier there to start even experiencing the amazingness of the three-dimensional VR content. And that's cool because a lot of devices afterwards supported hand tracking, and that led to kind of a freer way of using devices. Of course, headsets also supported inside-out tracking, so they could be completely used on their own. You can only have a headset and enjoy VR content. But this still led to a lot of these fatigue issues. So what we see in the most recent generation is the eyes and hands combination, where you use your gaze to look at something and pinch, something I've indicated before. Yeah, so coming finally to some stuff that we did in prior work in Lancaster, in Germany, but also in Denmark. There's been a lot of projects. A lot of stuff is even missing on this timeline, but yeah, I will take a look at the first few works, which I consider as more like the foundations of it. And later, we looked at advancing this paradigm. So it started in our labs, actually, even with Jason Alexander and so on, we was considering multi-touch devices, since multi-touch was the dominant device, and is still the dominant device, right? That the mobile phone and tablets. So the idea came with being, okay, let's attach an eye tracker on the devices and explore a bit what we can do with it. And you can see here, there's a little eye tracker attached at the bottom with a red light. The red circle here is indicating where I'm looking on the device. And I built this gallery app, which is very similar to the direct touch gallery app. And you can see that every gesture I do is actually redirected to where I'm looking. So the finger is not selecting, but actually my eyes. So thinking of that, the eyes will reveal my interest. And you can see that it's very, it's quite natural. So it makes sense to open that image that you're looking at. And that was the first part. And then it just continued to, when you actually in this menu, when you zoomed in, you can also do, you can easily look at the back button, go back to the original hierarchy. You can use two fingers to zoom in and out. So it just made sense that the default gesture set that can be in one paradigm extended to using with your gaze, so that you can actually reach anything now. You can interact with anything on the whole screen with just very small finger taps. And there's been a bunch of works that, so this is like a more final version of the prototype, but I've over years I had hundreds of small prototypes that combine the eyes and hands together to figure really out what is the right model there between the finger movements and your eyes and the UI composition you have on the screen. And it's been this specific approach where you only use the eyes the moment you tap. So after tapping, when you scroll or something, it's not gonna, it doesn't matter. Yeah. So I told you I did a lot of prototypes. This was an early one. You can see that I'm using gloves for better touch detection and so on, and a larger screen here and different eye tracker. But here I explored a slightly different mapping, and the use case is sorting blue and red pills. I don't know if there's an actual real world use case for that, but it didn't matter when I was just exploring. I was just thinking, how could I make this more efficient somehow? This typical sorting example that we see here and there. And this mapping was about how many fingers I put down will immediately auto-select the closest objects around the gaze. So this had an interesting effect of I can either use 1 finger, 2 finger, 3 fingers, and depending on where I look, I can just immediately drag them out. And this showed just, okay, even at this fast-paced, every single gesture control, I can still look somewhere, make the rapid decision, oh, this is now 2 objects or 3 or 1, or this is a blue one or a red one. I can make this at an instant, and also at an instant, I can touch down as many fingers as I need to continue doing the task. So I thought, like, okay, there is something that makes our eyes and hands compatible, and it also supports this dynamic, fluid way of interacting. So this has to be something, right? There has to be something that can be more fundamentally changing all of these manual devices we have. But I found that a key challenge is not only that we can now have a new interface that is gaze-based, but rather, in a lot of my demos, when I showed them to Jason, to Hans, to other people in my lab, it was still a bit unclear. Okay, what is the point of that? Yeah, you can do the things that you can do before, but is there a benefit? What can we study there? There's just lots of applications, and I guess the underlying concern is that do people really want to completely change the way they interact? Because things are working now. Why do you want to suggest this even, right? Even if some study can show, oh, there's a performance benefit here, but the problem is still, why do you want to change a working system, right? And what's the point of that? And do people even want to adopt that, right? Because if things are working, why adopt something new? There's a learning effort and other barriers coming there. So the key insight in the second paper in my PhD was that actually it can't only work to introduce a new paradigm. You've got to connect it to the old paradigm. So, and that's happening in several ways here. First of all, you can see that I can actually still do the normal touching, right? So here I'm using gaze and tapping to do, to just click on some buttons, but I can still do the same thing in the same interface with direct touch if I use my other hand. So this is the gaze shifting paradigm. And in a sense, this is the idea that every gesture can swap between either being direct or indirect. The indirect one is, of course, then gaze-based, but you can depending on your visual attention, you see my red arrow, that's kind of where my attention lies. When a touch is detected close by, it will be direct. And if the touch happened far away from where I'm looking, it will be automatically switching to the indirect method. And so this is one way, one aspect of combining or unifying with the old paradigm. So the user has always the option to just work manually. And the second aspect here that maybe is not fully clear at the moment, but even the indirect method of gaze and touch uses the same gestures, right? A tap is selecting button, and a dragging would scroll the interface. So it's doing the same as you would do directly. So these two aspects here. One is that the new paradigm works almost the same way as the old paradigm. You don't need to learn much. And the other aspect is that even in this interface, you can either use the old or new paradigm. It's totally up to the user. Still, so I hope this became clear, because this is a little complex in itself, but you can see in the demo that, you know, from a user perspective, it can be just that, oh, wherever I touch, you know, my action will happen where I'm looking, and that's all you need to know, actually. And this is so this is another example. I typically don't bring this, but this is the example of direct and indirect interaction extended to the stylus, which I think is the third important paradigm, that the stylus in itself also has this fundamental mental model of interaction. Like, we know exactly how to use a pen from the real world. And it is almost a ridiculous thing to suggest, let's combine it with gaze, because it would completely change this model, right? That you can, you know, why would you put a pen in your hand and then not just use it directly, because the metaphor is to use it directly. So there's a different challenge here in keeping up with the metaphor of the pen, so that user can still do the normal drawings and the edits and so on. Like on the left, you can see that the example best. So the user is just writing, but to switch modes to a different color, they can look up to the same little indirect pen input to change the color and then continue writing directly. And it becomes this very seamless way of quickly looking up at a menu to do stuff, and when you look back, you can just continue as you know how it works. So these are all the things I did in the 2D, and in the last year of my PhD, I had this work where I extended this model to 3 dimensions. So here's an example of a gaze and pinch, where in virtual reality, you look at the object you want to interact, and a pinching will immediately take over and control the object. And you can see that even if the objects are 2-3 meters away here in this scene, it feels like you're directly grabbing the objects. It's not like additional effort of thinking, or how do I point now? How do I move a cursor or something? It's like immediate action, as if you would directly grab the object, but you don't, because they're out of reach, actually. And it works for, you know, for coarse tasks to do quickly things, but you can also precisely position objects, because the key design division of labor here is that you point with your eyes, and then you can do little gestures with your hands. And the moment you start a pinch gesture, it immediately takes over, and the eyes have no effect anymore. Yeah, so even, yeah, I think I tried to build some Star Wars-like action. You see that I'm not very careful here, and things are breaking, but it's very easy to just put up these 20-30 objects to create some kind of model. So yeah, that was kind of the earlier work. Earlier work like gaze and pinch and direct and indirect gestures now appearing in the state of the art of the industry. So the Apple Vision Pro has gaze and pinch, direct indirect gestures, and even gaze and pen now. So Logitech Muse device. The new stylus is now supported also with the Vision Pro, and it also uses the direct, indirect, and gaze-based approach. So 3 pillars of the spatial interface. And I think the Galaxy XR uses gaze and pinch, but a little bit differently, the direct, indirect gestures. And the Vivo Vision, I don't know exactly, but I just know that they use gaze and pinch. Yeah, but in Aarhus here in our lab, we've been looking at what happens afterwards. What happens when gaze and pinch becomes kind of a standard, when a first generation of people gets used to it, people will also probably recognize what are the limitations there. What works well, what doesn't work well? When do we still need to revert back of the old paradigm? And when do we even want to have more of eyes and hands integrated? So all these works since around 23 have been focusing on that. And I'm actually missing about 10 papers that happened in the last 2 years, and last 2 and 3 years of this. And I can only give you a little glimpse of the research we do. And I hope it will make it clear kind of. But it's of course hard to understand what is the second phase 2 really about, because you need to understand, first of all, you need to be a pro Apple Vision Pro user. If you know the interface by heart, then you might agree with some of the limitations and some of the benefits that are there, and what can still be improved. And of course, the Vision OS had a lot of updates since its release, so some of the elements are actually already in. For example, when we, in 2024, we did all the work on the gaze and pen for VR. And this actually is now available, I think, since early this year. Also, we looked at two-handed interaction, which also was more, I think it got a better support last year. But yeah, so there's a bunch of things that might seem more obvious, and a bunch of things that are more into the future of maybe mobile and glasses-based use. And I want to just make the mapping here to say really what is the point of all the work. But some of the aspects are motivated by a still occurring problem of fatigue with gaze pinch. And some are about complexity of two hands. Some are about having more information rather than using the 2D direction of gaze. And some are a bit of deeper findings on pre-shaping and so on that a bit difficult to explain. But let's start with this. So you see on the left side, if you want to do a basic drag and drop in 3D, it looks like that with gaze and pinch, with the Apple Vision Pro, for example. So you look at the object, and then you pinch, and then you can move it. And this is the clear division of labor part of the foundation. So it's important that there's a clear division of labor, because it makes the interface easy to adopt. It's using the same gestures as you would expect from direct manipulation. On the right, we see something that Uta and Andreas have developed in this paper. So it's also probably a very obvious extension here. So when we do drag and drop actions, we also look at the destination. So let's move the object to the destination instantly, right? Because we're already looking there. And that was the idea. And it wasn't so easy, actually, because it's about 3 dimensions. So 2-dimensional space, we can easily just look somewhere and it will move it there. But we can't really move the object in depth, because our eyes cannot really change the depth easily. Unless, of course, we have different objects in our scene. But we wanted to have drag and drop that works without using any potential object knowledge of the scene. So I'm skipping through a lot now. We had 2 variations actually of look and drop, which you can see here, the left and right. And the key thing is that what you see here on the look and drop plus, the very right example, it's also in slow motion here. But when you select the object and then with your eyes, the object warps towards the target, we used an approach to be more precise at the end, because we found in our pilot test there were a lot of errors actually when you use the basic approach to just use your eyes to move objects. And here at the very end, the hand gets back control to refine the final placement. And this is something that has been there for a long time in the literature of HCI, that this approach of magic, so manual and gaze input cascaded, where you warp an object to your gaze and the hand does the final refinement. But this didn't actually work in this method. So we had to actually adopt a new approach, or a little extension to it, where not only the hand does the final refinement, but it's a combination of both eyes and hands are still active for final control. Well, I don't want to go too deep into this now, but as you can see in the results regarding the actual temporal performance, the task completion time, there was no big difference across the different techniques we tested. But we found that for the advanced look and drop plus versions, one of them, so most of them had actually higher error rate than directly using your hands, except for one look and drop plus version where we had this additional refinement. So the additional refinement allowed to reduce the errors. But anyway, the majority of users preferred the look and drop plus version, even if there was no difference in time or no difference in error rate in one technique, because of the arm fatigue. Yeah, that was the main reason. People were saying that, yeah, if you have to move your hands, it just gets quickly tiring. Of course, our study requires users to maybe for 5 minutes just drag and drop like crazy. Every 2 seconds, and you drag and drop. But it does indicate kind of what would be a long-term fatigue effect here. And because of that, all users, even in that short period of time of our study, and even if it was a bit more intense, there was a clear tendency towards using this new approach. So zooming out a bit, what does this mean? Maybe for a new generation of gaze and pinch, if there's activities and use cases where a lot of dragging happens, it might actually make sense to offer people the option to change the model slightly to look and drop plus. And then it's actually important to really consider the 2D and 3D translations that are happening and how to best unify them. So this is an application of the technique we proposed in that paper. You might know Bejeweled, the game on phones, on touchscreens, where you have you have 3 different, you have like a lot of different objects, and those with the same shape need to be put together. And the amazing master student, he built like the 3D version of the game, and just to explore how good can you actually become if you become a pro of this technique. And you can see in this one, the user is just very easily moving objects in 3-dimensional space with minimal hand movements. And this is with gaze pinch, it would already be quite a lot of moving around and effort. And you can see that with this approach, it becomes almost zero effort. But it's also for us, for me even, it's so hard to understand what is he doing? How is he coordinating his eyes and hands? But it's also, this is the exciting thing, that it indicates something in the future, that people will be able to coordinate this way. But it might be even beyond our current comprehension to understand, okay, how does it work in the brain that you can actually get so used to it to just look and pinch and do all these actions. But it's possible, and even if I don't understand it fully, it's so inspiring to see the possibilities of that. What kind of use case, what kind of activities could this actually improve in future? Another project I mentioned a bit is the two-handed interaction. I think I will probably have about 10 minutes left, right? Or 5 to 10 minutes. Just let me know. But I'm also going towards finishing up slowly now. So yeah, this has been an interesting study we did. Now that you have gaze and pinch, so again, the standard model, it's interesting for two-handed interactions, right? Because it's such a fundamental thing that we use our two hands in so many actions during the day. And now, at least for virtual combat in XR, it's possible that you can instantly switch the left or the right hand to be direct or indirect. You can either be on the object or not. And you can even have interfaces that support all modes at the same time. So here, Matthias, our PhD student, is just having this demo where it's about some kind of 3D modeling. You can see that it's very easy to reorient objects with your non-dominant hand. So here, the right hand, or the big model, and then use your dominant hand precisely to manipulate objects. And you can also see that sometimes it makes more sense to use gaze and pinch. Sometimes it makes more sense to use direct gestures. So this is an interesting space of how our two-handed actions will be in the future. And so we just studied the very basic approach of we studied all 4 possible combinations of direct, indirect, and left and right hand mappings for an asymmetric task. So as you can see, the left hand, the non-dominant hand, was used to kind of frame the actions of the dominant hand, which is kind of based on the original work by Gyat and then some follow-up work in HCI by Bill Buxton and so on that explored how we can integrate two hands better in human-computer interfaces. And here is the XR and Eye-Hand version of that. And what we observed in the study is that when people use gaze and pinch, it took them actually a bit longer. Well, let me see again the acquisition time. Okay, so we had one of the 4 that didn't work well, and it was the indirect plus direct. So this is what you see here at the bottom left. And this is all the other conditions. Somehow, people didn't really have any problems, but this one was really not liked at all. And this is because when you indirectly want to change the rotation of the object, and then you're already far away with the object, right, with your hand. And then if you need to directly manipulate the object with the other hand, it kind of becomes a bit of a harder coordination to do. And there's also the pre-shaping problem. So, well, there was a bunch of interesting observations. So even the distinction between completely direct control and indirect control, it wasn't just about performance, it was about comfort, right? And the user was able to, as you see, like this user is like leaning back a lot when they completely interact indirectly. So it's a different adaptation of the posture and using the environment around you. While with direct, people had this more straight up in front of them interacting approach. But the most interesting part is probably pre-shaping, what you can see here on the right. This is an example of how you of pre-shaping for direct interaction. So this is a positive example, actually. You can see that when I know I have to rotate an object in a specific way, I can already pre-shape my hand. So I prepare my hand to have a better rotation so that when I do the action after grabbing, I have an easier time to actually do and finalize the manipulation of the object. And why am I showing this? So this is a natural phenomenon. Like people just did this intuitively with direct gestures. But with gaze and pinch, it wasn't the case. So people were looking at the object and just pinching and then manipulated, so then they rotated the hand. And because they missed the more efficient pre-shaping that they do before the action normally, that's why the performance was a bit downgraded, actually. So when you do this indirectly, you can only rotate, if you don't pre-shape your hand, you can maybe only rotate the object for 50% of what you want. And then you need to clutch, you need to engage again with your hand. So there was, on the level of atomic action, it's not much of a difference, maybe a few hundred milliseconds and a bit of a coordination, and you need another clutch. But if you do this a lot of times during the day, and grabbing an object is a fundamental operation, right? So then it can be, it can become a bigger issue here. I want to give a quick teaser to our last year's work, just showing this video. And this is the last example before I dive into, just towards the end of the presentation. This is something we published last year at WIST, a work from Yang et al., one of our most recent PhDs. And the idea was that still, as in our previous work, we did find that object manipulation with gaze and pinch can be difficult to coordinate sometimes. So there's precision issues, but there's also this issue with pre-shaping that, and you need to clutch again. At every clutch, you need to make sure that you're looking at the object, right? Because otherwise you might just take the wrong object. So our goal in this project was to think of how can we make the general gaze and pinch interaction more precise. And we know with direct gestures, you are more precise and it's easier to coordinate. So we tried a few approaches. Can we somehow make gaze and pinch more direct and so on? But in the end, we thought, okay, to really to reap the benefits of direct manipulation, you've got to enable users the normal direct manipulation. So even if the objects are far away. And what's happening here is that we use a mechanism called gaze and alignment from our previous work. And when you actually, so you see that by default, you can look at an object and move it. So this is normal gaze and pinch. But if you want more precise manipulation, you can get a zoomed in view, or the objects actually move towards you based on a world in miniature approach. And this happens when you look at something and you move your hand towards where you're looking. Then this little bubble will come up, and this is essentially a copy, a proxy of the objects that are far away are now right in your hand. And what the user can do is they can precisely select the item they want. They can move the hand out, which automatically goes into gaze and pinch mode again. And then you can roughly place it somewhere. And when you then look at your hand, it will create this proxy again. And you still have the object in your hand, and you can just precisely position it. So it allows this flow of interaction where the user can, at any time, they can get this proxy view to directly take something or to directly to precisely position objects. And it's kind of, it feels like collapsing the space, because the far space and the near space are now instantly available. So it doesn't matter anymore whether things is far or close. And if you have a problem with the far content, you can just immediately get them right in front of you, even during the gesture. So these are some like more cooler interaction explorations we're looking at for the next generation of input. I mentioned there's been a lot of work recently that I haven't been able to put into my talk yet. So I refer to this slide, to a few pointers. There's also been a few works at CHI this year and ETRA. But yeah, just finishing up and zooming out a bit, what I think is an interesting next step to consider is this scenario of multi-devices. We do live in a world where in a lot of rooms we have different types of input and output devices. So what you see on the right is output on the right and input on the left. And in most cases, it's a one-to-one relationship. So I can use the mouse for my laptop. I can use the touchpad for my laptop. I can use the touchscreen on the smartwatch for smartwatch control. I can use the TV remote to remotely control the TV. I can use the phone's touchscreen to interact with the phone, and so on. And I know there are apps where, for example, for Netflix, you can use the Netflix app to control the Netflix content on the screen, and so on. Right? There's touchpad phones and so on, but it's still pretty fragmented, really. It's not an open way, right? If you want to use the mouse for anything, for the TV screen, or maybe even for the small screen you have on the smartwatch, it's probably a hell to figure that out. And an interesting aspect is, of course, that in all of these cases, when there's multiple screens around us, very obviously we probably look at them, right? So our attention indicates what we're interested in. And the question is similar to maybe XR. XR is a bit of a smaller use case for one device, but in that 3D spatial environment, it makes so much sense that the eyes now select the window, the eyes select the object to interact, the eyes select the window, the menu at the top, and then you can use your hands or other input devices already for that. And Apple supports the stylus, hand gestures, Sony controllers to do similar things. So this could also be something interesting for beyond XR, that we actually have it in everyday physical environments with digital technology, so that we don't have to put our laptop away to interact with the phone. We don't have to change anything. I could just, depending on where my attention is, that's an interesting aspect to consider. There's other interesting aspects, I think, in this for future work to consider. So a lot of the XR work is still just pinching. And of course, this is nice. It's the most simplest gesture you could probably have. But if you think that XR is not just one device, one paradigm, one use case, it's a lot of use cases. There might be experts to novices. There might be design use cases. There might be casual interactions. There is the stationary work. There's mobile work that you do on the go. So in a lot of work in the HCI field, people looked at the context. People asked users, actually, what type of gestures do they want? And there's been so much work introducing so many different types of gestures that people find intuitive. And it's entirely unclear how compatible all these gestures are with gaze at the moment. So right now it's for simplicity, gaze and pinch, yeah, but it's still a huge design space there. And then the second, back to the physical world, it's something I also mentioned with the just before with the Internet of Things and cross-device interaction in your environment. And you can spin that even further, right? That there's work by Hiroshi Ishii on radical atoms and tangible UIs, so that the physical objects become digital or have a digital counterpart, and you can kind of manipulate the space, the matter. So given that, it would be interesting to consider, can we have something like these old visions where people were doing some kind of magic to making objects fly in your environment and so on. And yeah, of course, if we zoom out even more, everything is done by hands so far for controlling computers, and also for in general, for machines, for, if I take any object in my hand, it's completely based on that. So now that it works in XR, and it might also continue with other devices, so it's interesting to think, hey, what if this would actually be part of everyday interactions with physical environments, and how will it change our thinking, even if the atomic step of every action is kind of shortcut in some way, so we can get quicker to finishing actions. This might mean we have more time to do other things, to think about stuff, to this might do a lot of things that we're just not aware of at the moment. Yeah, so thanks. That's kind of it.
right.
This is the recent post, and I hope to get some interesting questions or conversations with Jason.
Thank you very much, Ken, for this very comprehensive presentation. Jason, would you join the discussion with Ken? And
Sure. Yeah, thank you again. It's a fantastic talk. It's nice to reflect on some of that work we did many years ago back at Lancaster, still form foundations of what's going on. So one kind of question I had was, so we've seen some of that early work kind of get embedded in the Apple Vision Pro and these other devices. But I guess in my head, maybe the Apple Vision Pro isn't a consumer mainstream device. People, it's kind of a high-end device that people have. So what would it take to move this work into the hands of everybody, so everyone has a mobile phone in their pocket, right? So what's the barrier to getting these kind of XR interactions and all these kind of gaze-based interactions into the wider space?
Yeah, of course, that's quite a big question that in many things I don't have a clue, and a lot of things depend on the technological advance, right? You're right. The Apple Vision Pro, like as one example, is very expensive and probably used mostly in labs or so. But I think they're selling it as kind of a glimpse into the future that you can see. Okay, maybe in a few years we will have these, or maybe in longer we will have these as widely available as our iPhones. And it might be possible, might not. Then you can see other developments at the moment, like with the HTC. No, so the Valve Frame, not HTC, the Valve Frame. It's a new headset coming out sooner or later, and they seem to have advanced a lot on the weight part and making it more comfortable to use to have headsets. And then you see, like Google, Meta, they're so betting a lot on smart glasses nowadays. Okay, these are mostly AI glasses where you don't have visuals. You can, talk and have some, but they're already quite successful. And you can see that with the most recent ones, they also have some kind of visuals in there, whether it's just a HUD, HUD display, or whether there's some AR aspect where, like the Aura or the Snap spectacles, they indicate some possibility there that you have these lightweight glasses that could be, next to your phone or something in the future. So that's where I think that's the one, that's the wearable on that direction. And the other direction with phones and so on. I think there's a bunch of things to consider. I think one big challenge is still the perception of what phones are and that what gaze can be used for. Is that on the phones, it's such a small screen. What's the point of that? That's the first question, I think. The second question might be, it's such a small screen, we can't really track the eyes. It's so hard to get it working. But I think the tracking question might actually be solved at some point because there's so many advances happening with eye tracking anyway, and it becomes such a small sensor, and you can have a lot of cameras in theory and on the device around the phone. And if you have a more recent iPhone, there's actually an option in the system with eye tracking, so you can already use eye tracking with dwell time, so an eyes-only approach and a hands-free approach. It's quite inaccurate, I guess, to use, but as a just to see that the option is already in the interface, and the calibration of it is very similar to the Vision Pro and so on. So there might be already some thoughts within the industry to go in that direction, or at least offer the option, And yeah, but I still think the big challenge for maybe even in the community is to think, why would we want that, right? Because it works so well on the phone already. Nothing has changed for a decade. Like interface-wise, of course, a lot has changed, but the interaction is almost the same, right? But that's also the opportunity, I guess. There's a possibility that you can advance something, and then yeah, I think there need to be more studies. First of all, on one, understanding what are current problems with the phones. Most of them are probably unnoticed. Things like, oh, now I must use my other hand. There's no other way or I put the phone down. So that's like two use cases where you just, you just do something, even if it would be ideal to just immediately interact. And then there's a lot of cases, for me at least, where, okay, I am too lazy to use my other hand. I just want to have it in my hand. So I re-grip my hand to go to the top menu to maybe open or close the Bluetooth connection, whatever, right? So there's a lot of re-gripping happening that I think is also it could be there could be the potential, there could be a benefit there that if you use some kind of approach where you can just look at the items and tap on an individual action level, there's not so much of a benefit, maybe, or maybe I'm actually even slower or also. But if you think of the hundreds and thousands of taps we do every day, and all the billions of devices, if you can save 50% of the effort or something, that sounds, of course, amazing. But it sounds maybe even like too much. Right? Is it even possible to get there? Is it 50%? Is it 5%? It's hard to say. But I think these are as points where studies or HCI research can really answer some of the questions, so that actually the industry can read these works and get informed and understand, okay, there is some potential and can go on. But maybe it's also, maybe the other way around, right? That maybe there needs to be a working phone with eye tracking to then actually have people exploring new use cases of that. So yeah, I can see that maybe in the 5 to 10 years that the glasses or headsets and so on, that if they're easier, if they're cheaper, and whether it's just home use or whether you can really do this on the go is a different question, but I can see that coming. That was a long answer.
Yeah. No, that's super. So I didn't know about the eye tracking in the iPhone, so that's really interesting, right? So that hints at that what might be coming. So that's cool. I mean, I have a whole stack of questions, but you touched on one of them then about. And actually, earlier in your work, you did too, about how do you combine these modalities of interaction, right? So sort of, can you augment things? Can you add gaze as a layer on top of your normal touch things? And in your last slide, you also kind of sort of hinted at this idea that actually, there shouldn't be a one-to-one mapping for all your interaction devices. It should be, end to end or something. Have you any thoughts? So I know various people have tried to explore this kind of multi-input device space. Have you any thoughts as to how that might work, or where that direction might go?
Yeah, of course, I was thinking about it a lot, and just it's again, the motivation comes more from just observing some problems I have when I'm watching TV in the evening. And I guess it does become somehow already multi-device because you have the phone, the laptop. So I want to write an email. Oh, there's a message from my wife. I need to go out with the dog. Oh, damn, I need to turn down the volume of the TV. Things happening instantly. I can in theory use my laptop for that by going to the specific application to do all of that. I can open WhatsApp from my laptop and so on. And I can also, and so you see, like I feel like this is something that I want to solve for myself. And if you save one person, you save the world. So that was my. I'm probably diverting a lot from the original question. What was it?
Do you see gaze as
thought.
the potential solution to this challenge of how do I direct my interaction to all these devices?
So I'm thinking about that, but also in a critical way, I guess, since we're in academia, and that the naive approach would be, okay, now everything what I'm looking at, that's where the input will land on, and it's interesting as a high level idea, and then thinking, okay, where might it fail, where might it be good, and then again, okay, thinking we still want the old paradigm I still want to do all the things on the laptop that I'm already doing. Same with the phone, same with the TV. How can it be all working together, coexist in a way that I have the option to direct my eyes and the system knowing, okay, that's actually at this very moment, I switched bam and now I'm there. I don't need to switch an app or this and that or something. So I think that's already partly indicated in the Vision Pro, where you can switch between different windows. You can integrate your laptop or use gestures already and interchangeably. So that's quite advanced and indicates a bit in that direction, I think. But the big, there's so many different input devices and different output devices. It can be, I have this example of screens, but there can be, IoT things. There can be a lamp. There can be, I don't know, maybe an interactive fridge. So there's a big challenge of when do you want it to activate versus when do you want to just have it as you are comfortable with it for not centuries, but years or decades. So there's this thing again, but this is a much bigger thing. It scales up to all these devices, and then it just chaos, right? There's a few surveys in the literature and so on where and there's a bunch of cross-device work coming, I think every year, but it still doesn't seem like they really solved it, to really bring all the things together. And then there's this whole challenge with the industry that the kind of isolated environments of Apple and Google and so on. So there's a lot happening there anyway that you don't have under control in this cross-device part. But I'm hoping that with some collaborations with Google and that they want to extend their Android approach, which for mobile phones and general mobile devices is already like including a lot of cross-device interactions. And of course, also other companies like Apple have that. But I guess the Google Android direction is a bit more open. Well, I don't want to say anything wrong now. But yeah, I'm thinking that's an interesting direction to take. That maybe that can combine the XR devices with our mobile device and our home environments and so on.
Super. No, that's fantastic. Do I have time to ask one more, or should I let other people ask?
Can we first check if there's any questions from the audience first? Anyone want to ask any questions? I see Mark is also here. Mark, would you like to ask something?
Yeah, I have a question. Good to see you, Ken. Actually, I had a couple of questions, but one question was, I think your work's been really, really interesting. Do you think some aspects of it could be replaced by using head pointing rather than gaze pointing? So, some of the Quest 3 and other older headsets don't have eye tracking, but I imagine you could also do some of the techniques you've explored using head pointing rather than using eye tracking as well. Have you explored that before?
Yes. So there's so I have several points to add to that, but I think when you actually have the choice, and eye or gaze pointing is actually not just eye point, right? It's actually when I move my eyes, I often also in parallel move my head. So for me, it's a bit inclusive of the head point. So it's actually not the comparing eye versus head or something, but it's more like eye versus eye and head. And first of all, I know that there's a long line of recent research from Hans Gallassen's group that really innovated this interaction with head pointing and combining that with gaze and so on. So there's some interesting new ways that you can control hands-free. Because if you only use one ray, like only head pointing, there's always the problem of how do you confirm something. And I know that the previous devices that they did use, like the HoloLens 1, they had this air tap or like tapping on your headset and some. I think for those devices where you want, it makes sense. Just yesterday, 2 days ago, I talked to a student, and they had an exam they built a new prototype with where you had in the end hand ray pointing, but they said actually that during debugging, it was much easier to use the head pointing with with gestures. So there is something to it. I think that it's good to have that. And of course, it's more precise to use your head because you can have very fine movement, but also very fast movement. The big downside is, I think, still fatigue. Do you really want to move your head, Mark, around? For every pointing action, that could be a bit much. That's the thing. And in the end, the head is often used as an approximator for eye gaze. So ideally, you do have the eye gaze. That's kind of the more precise head pointing almost. But of course, as you said, there's so many different types of devices, especially the new glasses, right? They often only have hand tracking or something. And maybe for these cases, it's actually still an open question. Do you want to use the hand ray pointing or do you want to use the head pointing? And of course, if you think of the Apple Vision Pro, so you can go to the menu, you can change from eye tracking to head pointing or to hand pointing. But if you have the ultimate choice, I think there's still a little upside to the gaze one.
Oh, I definitely think gaze is better, but in some cases you don't have the option because you don't have support for it.
Yes.
I had another question was most eye tracking systems now use cameras, and because of that they have a limitation in the speed, typically 60 hertz or maybe 120 hertz. But there are some interesting eye behaviors that start happening when you go faster than that. So like microsaccades and things like this. So have you thought about what interactions would be enabled if you had eye tracking? So some companies, there was a company called Ad Hoc that got bought by Google. They had a very fast eye tracker that was 250 hertz. So have you thought about what interesting eye tracking behaviors or interaction techniques could be enabled by having much faster eye tracking?
Yeah, I think I can. I was often thinking of this in both directions. So one of my very early ideas was actually to use microsaccades
Right.
to improve accuracy of gaze pointing, because there is a bunch of work that showed that when you actually fixate on a point, your eyes are still moving, right? And you have the microsaccades. And I think then you have like tremor and actual microsaccades and plus a third type of eye movement within each fixation. So, and some of the eye movements, one of them is like the one that just changes your cursor for various reasons. So like if we could really identify that part or like these different sub movements within microsaccades, so can we somehow filter those out that make it less accurate, so that we would get even higher accuracy than we have now, considering that accuracy was a big problem for a long time. But the other direction I want to tell you that's been a big motivation for all of my work is that in HCI and eye tracking community, I often felt like at least before 2015, a big focus was on improving accuracy. So starting from magic, hand refinement stuff, that the assumption is just that it's not accurate enough. So we need some additional method to improve it. And this kind of changed the interaction paradigm in itself, because now the mouse was just one point, the eyes were one pointer and the hands were another pointing. So for me, that just broke kind of the natural interaction paradigm, that I can just look at something and immediately interact. And so while a big focus was on accuracy, I think this also kind of made it a bit blurry to what could be a really good interaction paradigm. And this goes back to the iPhone idea, right? That instead of thinking of a legacy, like a prior approach, you can put it in, you can use it like a mouse, then you need the accuracy, right? You need the eye tracking to be more accurate. But if you consider a device on its own, or the input device, or even eye tracking, that the most natural thing is just looking at something, right? You don't want to have anything that changes that you look at something, then you need to point again or something. So already making it like a two-step pointing approach can just complicate the whole interaction paradigm. And by making this division of labor, the eyes really just look and that's it. And any gesture will just work the same way as before. So there was an important simplification of it. There were a lot more complex, more advanced models before with eyes and hands, but I wanted, for me at least, to have a bit more of a different exploration, to get away from accuracy, to think, okay, this will be fixed in future, hopefully. And I think I was lucky that it was actually fixed with headsets, because the big change was that you have perfect head tracking now. If you have the head tracking accurately, then the eye tracking also becomes much simpler. And then nowadays, okay, it's still not perfect. There's still some issues, but it's already working much better than before. And I think for the interaction paradigm, it's so crucial that you use, that you're not starting with, oh, eye tracking is inaccurate. There's been actually work in HCI. Sorry, I've got to one more example. So when multi-touch came out, then there was this problem that, the fat finger problem. So you can't tap accurately anymore. That's what people were seeing as a problem. So we need precision methods for that. Some two-finger actions or some indirect cursor stuff. But, in the end, what really matters is just what does a user expect when you touch down? They don't care to be more precise than their fingers or something. It's just the button has to be a little bigger, and that's fine. So rather adapt the content and the interface to the input, rather than trying to adapt the input to the content that you already have from before. That was a big change in my own thinking compared to a lot of papers I've read. And that's I think important, to really think from ground up, what can this be really useful for?
That's great, thanks. That's all my questions. That's great, thanks, Ken.
Right. Following up on the answers to Mark's question, I also have one more specific about the tasks in 3D and VR environment. I see, Ken, most of your work were related to 3D object selection and manipulation. But in VR, we all know that there's another group of big tasks which is related to locomotion, teleportation, wayfinding. So how do you see eye and hand coordination will take effect in this group of tasks?
Yeah, it's so cool that you actually
visit stylist board, investigate teleportation.
that you actually ask this. I think understood. So actually, we did a recent work on teleportation with gaze in hand. There was the Kai paper coming out. Maybe I could give a quick example here. It's called Stylus Port.
Yeah, I saw that one.
Okay, you know it. Then, well, I tried to find an example. Anyway, this again goes back into this question of when does it really make sense to integrate the eyes. And what you can see is that gaze here is used for orientation control. That's okay. That's a bit. Maybe it's too much detail. It's not to go there. I'll just explain it. So, yeah, it's very open field, and we are, this is an interesting direction, and we are starting to explore some aspects there. But this one paper, we found out that the naive approach, for example, for teleportation would be, okay, I look somewhere and I tap to teleport there. But this actually was not a good idea, because when you want to teleport, you want to see kind of something. Where would you teleport? You want to have like this different type of cursor and array. And then even after teleport, or when you click the button, you still want to change the orientation of the teleport position. So we found that using gaze to teleport where you're looking didn't work well. But what made sense somehow is that after you set up the teleport position, that wherever, depending on where you look, will define your orientation after teleport. So in a sense, the idea that you can look where you look after teleporting. So if I just teleport somewhere in that corner, I look in the other corner, or I look at a specific object that I'm interested in, then after teleporting, I will still be looking at that kind of. And that was And that somehow made sense because it got you yourself the connection of you had this visual object. They will always tell you kind of where you are in the space of the room after teleporting, so that you're not you don't have any reorientation issues. So there was an interesting aspect in this, and this is very similar to a lot of the methods we use. That we look at, okay, does it make sense to really have it? And if not, we explore further and see kind of. It's important to find the right use case within that, and maybe it was just a small niche aspect of teleportation, that you reorient yourself afterwards, but it felt still like quite natural to do there.
Yeah. Thank you for sharing. I'm asking this question because a lot of my work is related to museum. A museum is object-centered. So like you said, if you look at something, you are not necessarily saying, I want to jump into this point, but rather I want to have a best viewpoint for this artifact. So we kind of explore ways of teleportation, combining gaze-oriented approaches. And that's what you described is also what we observed. So when I look at an object, I really want to like move towards the object to have a better view instead of jumping directly to the place. So I think there are a lot we can look into. We also explored ways like whenever there's a guide. So if your attention is attracted to the guide or to the object, then your teleportation behavior would be different as well. And backing to your point about the input and content, whether you are having the input and be presented by the content, or you have the intention with the content bringing up to you. So in the VR, teleportation doesn't always have to be you move in the environment, but the environment can also adapt it based on your input as well. So I see a lot of interesting aspect combining gaze, pinch, and teleportation. Yeah, this is a quite inspiring aspect.
Yeah, I love that. That's really cool that you have some insights there as well. So would love to get to know more about it. But also just see the basic gaze and pinch, basic clicking is just like the starting point, and then like navigation and so on. It's a much larger space of actually physically walking or kind of physically walking around. So that's so cool. Yeah.
Great. So any questions from the audience? If not, I think we are already half an hour over time. So let's quickly wrap up. And thank you, Ken. Thank you, Jason, again for joining us today. And also thank you, Mark, for the question. I think that will be all for today's webinar, and hope you have a nice day.